me just load my GitHub. 16 seconds left. Okay. Templates there. Yeah, everything seems good to go. Okay, the contest is starting now. The virtual contest. Problem set. Let's go. Basically just go through each pair of JSON elements and try to find out how many you need to add between them. So between I and I minus 1. And then if b is greater than c, then we swap them. 2 times b is less than or equal to, it's less than c. Then we need to add one more element, and that element will be the twice of b. Compile, let's try. Okay, it works, so let's submit. That's the first problem. So basically just create a count array, right? A count array of size 3. Now we need to know how to make these 3 counts balanced. Okay, so let's just iterate for like 5 times, and then each time we'll if c of I is greater than n divided by 3, then we need to move it to the next one. So that d be the difference, the answer increases by a difference. We'll move d over to the next one. Okay, I guess this simulation should work. I don't know why I chose 5. Maybe 2 works, but okay, it seems to pass. Submit this. On to problem C. It seems like just brute force. Or some sort of like 2 pointers. Okay, B got accepted. Let's move on. So, okay, they have to be positive. let B start at this number. And we'll do a loop with A starting at 1, A less than equal to less than this, and A will increase. And then if we end up not finding anything, then we just print no. So get a sample, okay. And then while A cubed plus B cubed is, well, it's too big, then we'll subtract from B. And if B is positive and the sum of the cubes is equal to x, then we can basically find the answer. So then we can return. Now let's check the sample cases. Yeah, it seems to work, so let's submit this. Problem D. It seems like a Cartesian tree or something. For each vertex, find the depth. So this is just really simple simulation. So how many problems are there? Oh, there's G, okay. So we start with N. Okay. Read N, and then we read permutation. Then we have our answer here. That's what we print in the end. To create the answer, basically just DFS. Left, right. And if L is greater than R, then we just return. There's basically nothing left. Now we find the maximum element in here. For J from L to R, max the max with A of L and R. So I need to make A global as well. Wait, A of L, A of J, and J. Okay. And after I find the maximum, so I need to pass in the depth in here. So answer of max of 1, that's the index, is equal to D. Now we perform a DFS. From L to max of 1 minus 1, D plus 1. Do the same thing for the right side. Okay, that seems like it works. So let's submit this. which players have a chance of winning. Okay, D passed. So basically just greedy. Oh, and it's pretty big, okay. So it's not that trivial. So let's sort off the elements first. Guess that's a start. I think we need to find the points where the sum of a prefix is smaller than the next element. Okay, I think I can do this. Eden, and then actually I'll make an array of pairs. If I is just equal to bi. Okay. Sort the array, and then start at s equal to 0. And I'll just take care of the output first. So that's the output. And then T will represent the sum. So here actually it's only until n minus 1. Then T, we add that to, we add AI0 to T. If AI, wait, or do we do it in the beginning? I think we do it in the beginning. AI plus 1, 0. If that's greater than T, then start has to be I plus 1, I think. For answer, we just basically start from S all the way to N, and then you push A of I of 1 into the vector. So basically the answer is just a suffix of the sorted arrays. Okay, this seems to pass. So here's F. We just make a new file, okay. G is ready. Accepted, cool. Isn't this trivial? Am I misreading? Oh, C. Oh, you can choose C. Oh, I see. Okay, C is not given. So let's just make a frequency array. And if we make a frequency array, happens is, oh yeah, I just make pairs and then it's just some weird calculation that we can do. Yeah, it should be pretty simple. So I'll just go ahead and write this. Read n, We have a map, Sweden A. Now it's stored in A. And now we only care about the counts, without storing C. So C starts out like this. We sort the counts, and then what happens is sum of the counts is n. So I want to maximize the rectangle that we can get. So let's just iterate over everything. So for this rectangle, we can get C of I times, that's the height, and then the width is n minus I. Okay. Okay, something went wrong. Yeah, I'm not supposed to use n, I'm supposed to use size of C. And then same here. Okay, this should be good now. Shoot. Four, 3, 6. I think I need to do n minus this. I'm maximizing the number of elements I keep. Okay. Okay, there, that's good. Submit this. Took a bit too long. Well, I just had a few bugs. Okay, G. What's a pointer to the first element? Okay, so this is just some. It should just be some binary search and stuff like this. I think it's fairly straightforward. And then vector of all numbers. We should take the prefix sum of these. So I'll put these inside B. And we'll pick another vector C which stores non-decreasing sums. C should start at like 0 or something. Okay, and then B of I plus 1 is greater than the back, then we push it onto C. Okay, now we have this you already should be able to answer the test cases. Oh, we put them in a... Okay. The answer could, yeah, it could be long. For M, we input X. Okay, now what do? You should find the first element in C, which is greater than or equal to X. If P is greater than equal to size of C, that means one rotation won't work. If we actually find it, then we need to store the index in C. Something like this. Okay. And here we just query X with like 0, something like this. Or just X. That works. Should work. Otherwise, the answer is C of P of 1, I think. We need to determine if it runs indefinitely or not. So if the total sum is greater than 0, then we know it will stop at some point. Okay, else here, we set the answer to -1. So how do we determine this case? We need to find the first so let's look at the last element to see. So let t be the number of times we need to return. So we take x minus the last element to C, which should be the max of all the prefix sums. You have to ceiling this divided by like b, by b of n, which is the total sum. And then this should give us the number of times it needs to turn. So what if this is negative? Then it will just give 0. Okay. Now we'll subtract x by b of n times t. Answer by will add n times t. And then we do this again. And this time this should work. Okay, let's try and compile this. Oh shoot. Looks like the compiler does not like this syntax. Okay, let's try this then. Okay, let's go. Interesting. Oh, I need to add. Okay. Let's see if it works this time. seems to work on the samples. Hopefully there's no like overflow or anything. I think I use long longs for pretty much all the variables, so everything should work out. Let's check. Accepted, cool. I was pretty lucky I didn't get any wrong penalties this time. Okay, got really lucky that I didn't get any penalties for G, because that was not an easy problem to implement. Okay, well, yeah, I guess this was an easier div 3, because I finished in less than 30 minutes. I guess I'll look at the editorial then to see if anything's different. Dense array. Yeah, that's what I did. Find this, and then we move. We move that. Yeah, okay, that's what I did. It's kind of checking this. Yeah. This is really just the standard way, a standard way to build a Cartesian tree. So, binary search. Oh, you can binary search by answer. Let's. Oh yeah, okay. I didn't use binary search, but I just used the linear solution. Cool, editorial. Unique values of C. Oh yeah, there's also square root decomposition because C is unique. I did the second one, so okay. G. It's just some G is just some math basically, and some simulation. Like finding the first prefix sum over a given number is a pretty standard binary search problem. Oh, I'm actually still first for some reason. I got really lucky this round then. Okay, well, that's pretty much it for today. Yeah, hopefully this was either enjoyable or somewhat educational. I don't know when I'll stream again, but I'll probably stream again with some contest. Next time stream might be one of these two. So unless I stream really within the next 3 or 4 days, it'll probably be one of these two. Okay, yeah, that's it.